To talk about my recent work on no boundary extremal surfaces in slow roll inflation and other cosmologies. So here is a brief motivation that we already have an understanding of holography through RT-HRT formulation of holographic entanglement entropy in ADS-like spaces. So it is further interesting to explore the quantum information ideas in the context of cosmology. So here we are going to study the no boundary extremal surfaces in the slow roll inflation models with perturbations to no boundary global ds, which preserves the spatial isometry. So let's first look at the brief review of the de-Sitter extremal surfaces anchored at future boundary. So the idea is the following, that analog of setting up the entanglement entropy of dual Euclidean CFT on the boundary Euclidean time slice should give us the codimension to RT-HRT surfaces anchored at the future boundary dipping into the holographic time direction. So the bulk extremization shows that the surfaces anchored at future boundary do not turn back to the future boundary. This has been shown by Narayan in 2015. Further, there are other possibilities which are called future past extremal surfaces shown by Narayan from 2017 to 22 for both the static and global coordinatization of the de-Sitter background, which shows that the future past surfaces connects the future boundary to the past boundary, and these are equivalent to the rotated Hartmann-Maldacena surfaces for eternal ADS black hole. Now, next possibility is that de-Sitter no boundary extremal surfaces shown by many other people, including Narayan, motivated by the idea that the Hartle-Hawking no boundary proposal, which says that the Lorentzian de-Sitter evolves in time from the no boundary Euclidean initial configuration. So, if we cut the global de-Sitter in the middle and join the top up with the bottom hemisphere, then it is giving us the no boundary de-Sitter extremal surface. These are also the analytic continuation of the ADS-RT surface on a constant time slice. And the area of these extremal surfaces are something called pseudo-entropy or time entanglement. The real part of this area comes from the hemisphere, and it is precisely half de Sitter entropy. In 23, Narayan has shown that some heuristic Liquich-Maldacena replica formulation of this no boundary de Sitter extremal surfaces, which says that the area of these surfaces are basically the area of the cosmic brains created from nothing, and these are basically the de Sitter entropy. Here we have studied the no boundary no boundary extremal surfaces in slow roll models, where the background metric component has this complicated form shown by Maldacena, where beta greater R is the slow roll correction. Here we have computed the IR no boundary extremal surface areas, which can be computed by defining appropriate contour to avoid some pole at the complexification point at R equal to 1 in the complex time plane. In order to the reason because of doing this is basically to avoid the divergences arise at the complexification point in the complex time plane integral. In order to do that, we have defined a new variable z. Also, we have shown that it can be done with respect to the original variable r. So the result shows that the finite part of the slow roll correction is of this area precisely matches with the finite parts of the de Sitter wave function of the universe. This further gives us interpretation that the probability for creation of this universe with the slow roll correction precisely matches with the cosmic brain maximal cosmic brain creation, which further corroborates the heuristic Lipwich-Maldacena interpretation given by Narayan in 23. To give it a context, we already know for the ADS black hole, the IR-RT surface wraps the horizon, and the finite piece of that area is basically given by the black hole entropy. We have further shown that these no boundary extremal surfaces for de Sitter DS3 slow roll inflation and for Schwarzschild de Sitter black holes with small mass considering as the perturbation. Thank you.